Okay, here we are again. And again, my goal with the sequence of these videos is just plot functions. And for that, we are using the Octave environment, which is properly for numeric computation. So you can use this environment if you wanted to solve functions with one variable or two or more than two variables. And in that case, we are talking about uh, plot functions of spatial function. Okay, so we start with this basic one, which is, which is a function that I said uh, you saw with very often in your high school days. And as we are trying to get better, to do best, now we are doing this also with this powerful tool, which is the Octave. So we saw um, how to do uh, a sketch by hand, just paper and pencil. So we plotted uh, x square. I mentioned also some characteristics of this function, like is symmetrically, as you can see, both sides, the negative side of the x-axis and the positive side, both are equal. So as well, we can mirror the sides. Uh, we also plot, uh, do a sketch and plot the function x cubed, and I commented that this function is symmetrically but not mirrored. If you mirrored one of these sides, the other side will not be equal, so it's not, this function cannot be mirrored. And okay, I'm not a math teacher. I'm just doing this because I'm very into signal processing, and I said that if you're persuading this field, which is signal processing, um, it's good if you have a good sense of functions. This is very basic ones, and if you are asking how this can be related to signal processing, well, you can start by doing a decomposition of each segment of this function. So I'm saying like right here we are not using the base time, um, so we can adapt this problem, of course. Right here, instead of x, we can use the variable t, so is a function of the time, so f of t is equal to t squared, something like that, I don't know. And we can even right here in Octave discretize this function. So right now we are talking about a problem of signal processing. And why we uh, will do this, why we will discretize this function, I don't know. You can also pick specific size, sorry, a specific point of this function. So is f of t, but now as we are mentioning this variable t, let's say we are interested in the, it's something that is happening on this function on 2 seconds or on the second tree. Um, you got it? You got it? So we can study each um, period, each time of this function if is a function of the time. So we can do a analogy of these functions of x now with um, doing an analogy to a function of the time. Okay, so of course doing a adaptation to this problem, and if you start on a nature or I don't know in finances or something that you can apply a square function or a x cube function. I don't know if you are studying volume of something. We have to be good in functions if we are interested in signal processing. Of course, usually courses in signal processing doesn't start with this type of content, but again, this is just the basics. I'm interested in in to know how to plot these functions with the Octave. And right here we are using very basic commands. We are not doing any applicable or fancy or um, sophisticated programmation. We are not using complex program language. We are just doing basics, just like specifying the time base or exactly the access and just passing the function to the Octave and asking to plot this function. Okay, so continuing with this counting and having this argument, right now we will study the again just doing a scratch, but now the function will be 1 over x. This is the function that you see when we are starting at least my my teacher of calculus start with this function when before getting to limits, and you find out why this. Okay, so as we are doing, we just have to pass values to this function so we can cover the x-axis. So we pass the most points that we can to have to represent very well this function. So x and f of x, which is equal y. So 1 over 2 minus 1 over 2, 1 over 2, uh, you know, anything divided by 0 is 0, but um, I'm covering this axis, so just for let's clear this. Sorry, very sorry right here. 1, 2, of course. And now 1 over 2 and minus 1 and minus 2. Okay, let me got more space. Now it's just simple algebra. 1 over 1 over 2 minus 1 over 2, so is 1 over 1 times 2 over 1, so that is equal to minus 2 minus 2. Now 1 over 1 is equal 1, 1 over 2, and anything divided by 0 is equal 0, and now is a positive 2, and it will be minus 1, and it will be minus 1 over 2. Now we just have to pass these values to this axis. So 0 minus 1 over 2, which is equal 0.5, and minus 1 and minus 2, and right here, still right here, 1 over 2 1 and 2, and right here f of x just the same as y, 1 over 2, 1 and 2. Here the same, minus 1 over 2, minus 1 and minus 2. This is very out of scale, but it's okay. We can still represent the function, have a face of this function, and after plot in Octave. And do some comments about it. So now we just have to connect the dots. Very easy. Again, this is something that you saw on your high school. It's a very simple function, nothing complex. But again, my goal right here is to plot these functions in Octave because it can be intro in signal processing. Okay, so for the first points, minus 1 over 2, we got minus right here. Minus 2. Okay. And right here in 0 to the x-axis is the point that I will say that we have a inflexibility that is a inflexibility function, but that's not true because after we sketch this function, we can discuss this. For x equal 1, we got 1. Okay, for x equal 2, we got 1 over 2 Okay. For x equal 1 over 2, we got 2. And for x equal minus 1, we got minus 1. And for x equal minus 2, we got minus 1 over 2. And again, if we cover more points, we can represent this function even better. But we can do a good sketch with just the 6 points. Okay. And remember that I said your teacher teach you this before get into, at least my do this with me before start with talk about limits, before start to discuss about limits, and now you can see why. Because on this y-axis the function diverges, so it never ending. um, okay, so what else can I say about it? The first thing, uh, and again, I'm not a math teacher or calculus teacher, but I just wanna pull up these functions, and I don't know exactly uh, the application of this function 1 over x. Uh, all I can say uh, for now is something that you saw with your teacher on your classes of calculus, because um, if we apply limits, applying limits, we can study if diverge uh, or not, and we know that this function diverges just by looking at it. It diverges. As you can see, um, it never get end. We don't have a value, a limit value, a finite value. Finite value is better, is best. So we don't have a finite value, and this is going to infinite. So it's diverging. What else? Again, is also symmetrically. This function is symmetrically. Again, just like this one is symmetrically, but we cannot mirror. Okay, I think I talked too much about this, and now we can start with our programmation. Let's try to plot this function right here in Octave. Just like we have done for the other functions, let's just establish a range for the x-axis. So establishing a range is very simple. We just have to uh, name these variables and pass to these variables um, a limit value. So it is ranging from let's see, -2 to 2. So that is the range of the x-axis. Now let's construct our axis. So we will use the function linspace to build this axis. And now let's pass to the arguments as argument. So these variables xmin and xmax right here they are passed as arguments, and let's also establish the number of points, and the more points that we attribute, more precisely this function will be visually. Now the function itself y uh, is equal 1 over x, and right here we need to use this point. And again, you can run it, but Octave it won't plot nothing because we did ask to it. So we need to ask with the plot command. So plot the x-axis and the y-axis. Okay. Uh, it's not like it's not something that we were expecting, because the function um, and this function it looks like is our intuition to say that is a discontinuous function, and that is incorrect. This function is continuous. It just got this uh, symmetrically appearance aspect. Um, it looks like it is a discontinuous function, but is a continuous function. It just got this aspect being on both sides of the xy plane, and now we are facing this, which is not like it doesn't look like this function that we have done by hand, that we have sketched by hand. So we need to do a modification on this code to try to illustrate, to plot the function just like how it is, okay. So to do this we will split into functions, something like right here y1, and right here y2. So we will split into function to represent the face of this function, 1 over x. Okay, and also right here we will change the strategy. Right now we will specify like in form of a vector. So x1 is equal minus 5 in the precision or step, and minus 0.01, and so there's these two vectors. So as right now we are specifying vectors, we don't need anymore this line space function, so we can plot it. And let's just plot just one function, because right here, right now we have two functions, at y1 and y2. Okay, let me see. I think it's this. Right here, x1, x2. Let's see. Exactly. And right now we need to plot the second function. So right here the arguments are the x-axis and the y-axis. Okay, it doesn't work because as you can see right now it is plotting the second function y2. What we need to do is to pass this command, hold on. So this first function y1 will be holded on the screen on the window. Exactly. And let me just try this. Okay. And this is how we can plot this function, f of x equal 1 over x. And again, what is interesting of this function is before we got on the limit discussion, we saw this function because right here is where we can start to discuss about limits, because it is very intuitive and we can have a sense of what is diverge and what is infinite. Is a good function to have this, to build this intuition and sense. Okay, so I think it's all for now, and now it's up to you to find problems in signal processing in which you can apply this function. Again, to signal processing, it has is divided in a good sense of math and also a good sense of programming language. And the Octave is a nice tool to start with it, and you don't see it's not common to start to discuss about signal processing just discussing about functions. It's more common to see the getting right into discretization of signals, and you can do this right here, but it will require of you a good sense, a good knowledge on this language, on the Octave language. And as we got more deeply on the subject, as we go through it, uh, we'll of course discretize function, and it's more common to see courses in signal processing start with sinusoidal functions and discretizing these functions um, because it's a good function to represent the most common signal on the real world, which is sounds, wave sounds, and so we can work with um, sound files, something like that. But right here, we are trying to build a intuition and a sense of functions and how they can be plotted and how we can also adapt to real world problems. Okay, that's it. Thank you. Bye bye.